There it is. 6, 4, 2, 1. I'm going to wait for the random 5.
Yeah. So it's recording, though.
It is recording.
Hmm.
But the countdown's a mystery. 6, 4, 3, 2, 1. I'm just going to wait till there's a 5. If it takes an hour, it takes an hour. Okay. And we are live. Good morning, everybody. Andrew, Fred, or he might be on there, he might be up there.
Yeah, you never know where I am.
I don't know. Depends which platform it goes out on. But we're on Facebook and YouTube, and we're on both the official Space Nuts Facebook page and the podcast group. So I'll just hide my coffee cup. No one wants to see that. And I told you I bought a little red car to drive around.
A little while ago, was that?
Yeah, a little while ago.
Yeah.
I love my little red. There it is.
Yep. That's a Mini.
That's a mouse.
Yeah.
No, it's it's about to be traded in, sadly, but
yeah, you were very happy with it.
I love it. I love it. I'm going to miss it, but onward and upward, as they say.
Oh, well, maybe. So you're trading it in for the Mercedes?
Yes, the Toyota version of the Mercedes.
Right.
We're getting a hybrid, actually. We're going to
good on you.
Yeah,
good on you.
Because out here, that's very handy because you can get about 1,000 kilometers to a tank.
Yeah.
Which given the current prices, $2 a litre. I know they're whinging in America about having to pay 80 cents a litre equivalent, or 60 cents a litre. We're paying $2, and in American dollars that would be about $1.40-ish, $1.60, $1.40, something like that.
Yeah,
so
or something.
We're much worse off than you.
We had a hybrid in Tassie for that ill-fated tour around the island, but it was great. It's fantastic.
It'll take a bit of getting used to because they're a very different type of machine. But it's been a long wait. We ordered it in January.
I believe that's the case. Ordering new cars these days is a long time, no matter what sort they are.
But it's going to be here at the end of the month. So, right, I think we're good to go. We better do the TikTok promo. Because 3 people looked at it last week, so it must be worthwhile. Okay, you all set?
Indeed.
In 3, 2, 1. Hello again. I'm Andrew Dunkley, the host of the Space Nuts podcast, and good to have your company. Coming up in episode 304, Fred, what do we got?
Well, you've got some great stories, Andrew, as always. The one that's fascinating me is the story about the Black Widow binary.
Yeah,
work that one out. Yeah, and also another story that I think is quite an exciting new citizen science project that I think we might get some interest in from our listeners as well.
All right, very good. We'll also be answering some questions about a strange light that somebody saw, and Fred knows what it was.
Maybe.
Martin is asking us about terraforming Mars. He's got a pretty weird idea on how that could happen. Radical. Sandy in Melbourne is wanting to know how we know extrasolar objects are passing us by. What's the difference between that and something that's come out of the Oort cloud or the Kuiper belt? We will answer those questions and much, much more on episode 304 of Space Nuts with myself, Andrew Dunkley, and Professor Fred Watson. Download from your favorite podcast distributor. That'll do.
Sounds good.
Yes. All right, I've got everything lined up. Are you ready to start, Fredo?
Yeah, ready to go.
You got rain there yet?
We've got showers going through.
Yeah, we've got a big system coming down on us. It's going to rain. It's just started, and it's probably going to rain till 2 o'clock tomorrow afternoon. So what's that? 29 hours. Yay.
It's not as though you don't need it.
Well, as the farmers like to say out here, there's money in mud.
Yes, there is. Yeah.
All right, here we go. In 3, 2. Hello once again, and thank you for joining us on Space Nuts. It's all about astronomy and space science. My name is Andrew Dunkley, your host, and it's great to have your company yet again. On this week's episode, episode 304, we're going to be talking about black widow binaries. Now, I'd never heard of that, but and not many of them have been found, but they've found a new one, and it's a pretty extraordinary one at that. So we'll talk about that. And a citizen science project involving the Rosetta Mission. We might be able to get you involved somehow. And some audience questions about strange lights, terraforming Mars, and extrasolar objects. We'll tackle those later on this edition of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Yeah, it feels good. I feel good. You feel good. I hope Fred feels good. Astronomer at large, Fred Watson, who joins us every week. Hello, Fred.
Hello, Andrew. I do feel good, actually. Yeah,
That's good. You're looking good.
Oh, thank you. Thank you.
Looking very swish, actually.
It's the old, the old Carl Sagan look with the
Yeah,
collar,
yeah.
which I
like.
tend to gravitate to in wintertime, and that's where we're heading.
Yes, well, as you can see,
Yes,
I got a thicker sweater on this week.
Woolly jumper,
Yeah. You know why they call it a woolly jumper?
It's something to do with sheep, probably.
Yeah, they crossed a kangaroo with a sheep, got a woolly jumper.
That's right. That's
That's
one.
what happened.
Yeah, that's it. Ta-da.
It's an old joke, but I thought our overseas listeners would like that.
It was rubbish when it was invented, and it's still rubbish.
Still rubbish. Oh, dear. Now, we've got a few really interesting topics to discuss this week, and let's hit the ground running with the Black Widow binary. Now, I'd never heard of this, and I've done a little bit of reading, and they haven't found many of these, but this latest one that they've discovered sounds like it's a pretty extraordinary thing. But I suppose we ought to explain first up what a Black Widow binary is.
It's a name given to an object that basically consumes the partner that it's got that has really nurtured it in the past. So exactly as the spider does, which eats its mate, that's what's happening with this binary object. And this particular one, Andrew, is even more interesting because it's probably a triple object. It's probably a Black Widow triplet, which involves 3 stars, one one is one of our old friends, a neutron star. And so the neutron star, very, very dense material, 1 teaspoonful weighs 1 billion tons or something like that. I can't remember the number.
You're talking about my brain now, aren't you? Very dense material.
Yes, that would be a neuron star, Andrew. Boom, boom. Anyway, never mind that. So they have very intense gravity. They're very compact, city-sized, perhaps 10 kilometers across. And they're formed normally by the explosion of a normal star at the end of its life, when the outer envelope of the star is blasted out and the core itself collapses. And all that stops it from collapsing to a black hole is the outward pressure of the neutrons jostling together. Hence the name Neutron Star. Mm-hmm. So neutron stars, basically, they often, and I think probably all of them, rotate, and many of them emit radio waves and other electromagnetic waves, including X-rays, along the magnetic poles, which may not necessarily align with the rotational poles. So you've got this phenomenon a bit like a lighthouse beam flashing. And that's basically what we see. Often with these things, you see the flashing lighthouse beam of the neutron's radiation from its poles, and we call that a pulsar. We've known about them since the late 1960s, 1967. So what's the deal with the Black Widow? Well, neutron stars, basically, over long periods of time, and we're talking about billions of years now, they lose energy, they slow down.
Yeah.
But occasionally, they might find themselves in a multiple star system, like a binary where 2 stars are orbiting their common center of mass, and will start sort of feeding Well, yeah, basically they get spun up again by material that they've drawn off the companion. They fed off the companion star. And that spins them up. And as a result of that, they get more energy and they start gobbling up the companion star more rapidly. So that is the idea of the Black Widow, that it's eating the thing that actually revitalized it. So this particular one is one of probably 20 or 30 that are known in our Milky Way. It's about 3,000 light years away. It's got a wonderful name, Andrew, ZTF J1406 plus 1222. And it's highlighted by being a very compact binary system with the pulsar itself and its companion star orbiting each other every 62 minutes.
Wow.
So it's got this 62-minute rotation period. And that's actually what has led to the discovery. It's an extraordinary thing that most of these things have been discovered by their X-ray emission, because, as I said, they emit X-rays. This one's very quiet in the X-ray radiation. But the way it's been found is by the fact that this orbital period of the neutron star and its companion, the neutron star is very hot because the other star is so close to it. It's been locked in to permanently face the same side towards the neutron star. That side is very hot and bright. The other side is cooler and dark. And it's that 62-minute flashing as that bright side of the companion star points towards the Earth, as it goes around the neutron star. That is what has been detected. So it's been detected in visible light with, a standard telescope. In fact, one quite close to my heart, something called the Transient Factory at Mount Palomar. It's a telescope almost identical to the UK Schmidt telescope that I used to operate at Siding Spring Observatory. So that's how it's been found. But as I mentioned, there is another star that is not yet fully confirmed, which is much, much further away. And the thinking is that third star orbits the other two, not in 62 minutes, but in 10,000 years.
Good grief.
Because it's so much further away from the center of the pair. Extraordinary, an extraordinary scenario, which raises, I'm sure, as many questions as it answers.
I imagine so, yeah. Are these things rare because they're hard to find, or there just aren't that many of them, probably?
There aren't that many of them, I think, is the answer. I mean, neutron stars are commonplace. Pulsars, I don't know how many pulsars there are measured in the Milky Way, but it's in the thousands. Which are essentially single neutron stars. But neutron stars in pairs or with binaries, they're also relatively common. In fact, there's one known pair of neutron stars orbiting each other. But this Black Widow idea, where you've got one feeding off a companion, I think that is the rarity about this.
Yeah.
And they're not common objects. And that might be due to the way that they're formed, because we think that they've probably been formed in what's called a globular cluster. That's a really dense cluster of stars, where at the center of a globular cluster, stars are, they're not jostling each other, but they're packed much more closely together than they are in a, for example, in our neighborhood of the Milky Way galaxy. And the thinking is that what's happened here is that there's been, these stars have been so close together that one of them's turned into a neutron star. It's grabbed one of the others to go into orbit around it. And the third one has wandered into all this as well and have this period. And then possibly the gravitational pull of the center of our Milky Way galaxy, which, as you know, contains a supermassive black hole, maybe that's sort of dismantled the cluster itself and left this trio of stars wandering through space.
That third star in the system's obviously been keeping a close eye on the news and maintaining social distancing, because otherwise it could be pretty hairy.
Well, you never know what you might catch from a Black Widow.
No, exactly right. You certainly don't want to get bitten by one in this country. We don't call them black widows; we call them redbacks, but it's the same family.
Yeah.
But is this? I know there aren't many of these systems that, as you said, maybe up to 30. But are they doomed to self-destruct ultimately? If you're eating your neighbour to remain fueled up, I mean, it's got to end in disaster, hasn't it?
Yes, that's right. I mean, unless it finds a new neighbour to tuck into, it will. Basically, I guess the end point is that the star, the companion star, gets demolished completely.
Yeah.
And that leaves the neutron star to its own devices, which over billions of years will, as I said, will slow down.
Okay. What can we learn from something like this? Is there any science that we can get out of it?
Oh, absolutely. And one of the mysteries in this story, Andrew, is that there's been no X-ray or gamma ray emission detected from this object, and so which makes it unique actually, because all the other ones have been found because of their X-ray emissions. So this one, excuse me. So there isn't immediate proof that is a neutron star in the middle. That comes about because of the way the pair, the dynamics of the pair. You can work out what the relative masses are by the dynamics. So it's I suppose it might be better called a candidate black widow binary rather than a confirmed black widow binary, because we're not absolutely certain that the neutron star is there because we haven't seen any radiation from it. But it may well be that with increasing sensitivity of these high frequency telescopes, gamma ray and X-ray telescopes, something might turn up. So I'm sure it will be monitored even more closely than it has been already, Andrew.
Absolutely, yeah. Okay, it'll be something to keep an eye on. We've only got a couple of billion years to figure it out. So
yeah, that's right.
Yeah. But it does sound, to use a colloquialism, like a hot mess.
Hot mess would be good. Yes, that's right. That's
mess.
a good description. Yes.
I heard that on a reality show.
I don't think I can follow that one.
Fair enough. All right. If there's anything more to report on that, we'll let you know. This is Space Nuts with Andrew Dunkley and Professor Fred Watson. Okay.
Right.
It's all good. Okay. We might as well continue.
I suppose so.
Yep. Here we go. In 3, 2, 1.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Now, if you would like to support Space Nuts monetarily, you can do that by becoming a patron. Now, there are a few options which are on our website, spacenutspodcast.com. And you can just click on the supporter link and find out more about it. But being a patron, you will get a few bonuses and benefits. You'll get the ad-free version as well. And you'll get an early edition. So you'll get it before anyone else. But yeah, there are all sorts of benefits. And it's up to you as to how much you want to spend. And if you don't want to sort of make a regular contribution, you can just do a one-off donation under the buy us a cup of coffee link. And the other way you can support us is by leaving reviews, by basically whichever podcast distributor you use, you can put a review in there, and that helps spread the word and get more people involved in listening, and they may even join the Space Nuts podcast group on Facebook and become another part of the family. So all sorts of good things that you can do to help Space Nuts grow and prosper. And for those who've already done that in whatever form, we thank you. Now, Fred, I love this story. I love the headline, Spot the Difference. Spot the Difference. Now, this is a citizen science project involving the Rosetta Mission. Now, I suppose what we should do is sort of review the Rosetta Mission so people can be reminded as to what that's all about. and then we can get on to what they can do now.
Yeah, that's a good plan. And Rosetta, that was a project very, very close to our heart, because you and I talked about it endlessly.
We did.
When Rosetta was in orbit around Comet 67P, otherwise known as Churyumov-Gerasimenko. I hope I'm pronouncing that correctly. And by the way, those two astronomers who discovered this comet back in 1969 are both of Ukrainian origin. So their names are highly Ukrainian names. It was in orbit around 67P between 2014 and 2016. And during that time, the comet basically made its way from the outer region of the solar system, excuse me, beyond the orbit of Jupiter, into the inner solar system, and went through what's called perihelion. It wasn't a comet that plunged deep into the inner solar system. I think it was still beyond the orbit of Mars at its closest. I can't remember. Actually, let me just check its orbit. Orbital characteristics, perihelion. Oh no, it's beyond the orbit of Earth, but not beyond the orbit of Mars. Its nearest point to the Earth is at 1.2432 astronomical units, which is 1.2432 times the distance of the Earth from the Sun. So that was its nearest point. But of course, when a comet gets to its nearest point, a comet is a dirty iceberg, as I think Fred Whipple called them back in the day. Fred Whipple. There's two Whipples in my mind there. I think Frank Whipple invented the gas turbine, didn't he? Is that right?
I don't know.
I think that's right. Yeah. Anyway, when that dirty iceberg gets near to the sun, excuse me, the sun's radiation essentially evaporates the ice in it. It doesn't evaporate. It sublimes, goes straight from a solid to a gas, and that induces changes in the object itself, because you've got these jets of gas spurting away from it. And so that, the amount of data that came from Rosetta was colossal. Huge numbers of images of this object. It rotates once in about 12 and a half hours. It's an object, roughly 4 kilometers across and wide. It's shaped like the classic rubber duck, the rubber duck in space.
Yeah, that's right.
It's got two lobes, a big one and a smaller one, and they're joined together. These are two separate objects that have stuck together under their mutual gravity at some point in the early solar system. Very ancient objects, excuse me, comets typically. And so well worthy of study. And Rosetta did a brilliant job. The only fly in the ointment was the poor little lander whose name was it Pillai? I can't remember the name of the lander. It was the name of an island in Egypt, which I actually would have visited, except they moved it when there was a dam built. Anyway, that smaller Pillai, that's right. Yeah. Pillai. So it landed and sadly fell over. So it was its solar panels were in the shade, so we didn't get much from it. However, what we did get from Rosetta was thousands and thousands of images of the comet from all angles as the Rosetta spacecraft orbited it, both before and after perihelion, the closest point of the comet to the sun. And so what the European Space Agency has decided, because that's the organization that actually operated Rosetta, they have collaborated with one of the big citizen science projects called Zooniverse, which I think we've talked about before, includes many different citizen science projects, many of them relating to astronomy. So Zooniverse and ESA have launched something called Rosetta Zoo. And the idea is, exactly as you've said, spot the difference. Look at pictures of Rosetta taken before and after perihelion passage as it's swung around the sun, and find the difference, because that's really of big interest to the planetary scientists, the cometary scientists who are working on this. You're looking for things like changes in the landscape, like icy boulders moving on the surface of the comet. You're looking for evidence of things kind of fragmenting, the landscape changing because of the fact that you've basically got these volcanic eruptions taking place in the comet as the gas that's subliming beneath the surface blows off some of the surface. And indeed, we had images from Rosetta taken near the time of perihelion when it was possible to see objects being blown off the surface.
Yeah.
I used to show a bit of footage of one of those in my Rosetta talk, which I haven't given for a long time. It'd be nice to revisit it. So that's fine. Seeing things being blown off the surface is exciting and great. But what you'd like to know is what it leaves behind. Does that open up interesting areas of the comet's surface where a further study of the images might show a bit more of the structure, the internal structure of the comet? So that's the deal. I think there's a collaboration involving the Max Planck Institute for Extraterrestrial Physics near Munich, in Germany, which is involved with this. In fact, it's one of their scientists who conceived the idea and kicked the project off apparently a couple of years ago. So we've got it now come to fruition, and I think that it's something that some of our listeners might like to be involved with.
Yes,
check out.
If they do want to get involved, the best thing to do is go to the zooniverse.org website, because that's where you sign up to get involved in this particular project. So zooniverse.org. And there's a lot of slashes after that, projects, blah, blah, blah. But zooniverse.org is where you need to go and find out more about spotting the difference with Rosetta, which could be very exciting, especially if you find something that no one else has spotted. That would be a coup. Get your name on a scientific paper.
That's happened. That's the wonderful thing about citizen science. You never know where it's going to wind up.
Yeah.
Some people have become quite famous because of unusual things that they've discovered. So just adding to that the fact that it's online, it's free. You don't need to install anything or sign up. It's just one of those classic spot the difference puzzles.
Yeah,
I think it's brilliant.
And just to make sure you can actually sleep tonight, Fred, it is Fred Whipple, not Frank Whipple.
Okay, thank you. Frank Whipple did invent the gas turbine.
Yes, he did. Just as a side note, do we know what the fate of 67P will be? Is it still doing what a comet does, or is it, going to vanish forever?
No, it is. It's in an orbit. It's not, its orbital period's 6 years, if I remember rightly, something like that. So it's not one of these that swings round past the sun and then disappears into the depths of the solar system. It's part and parcel of the inner solar system. It probably did come from the outer depths of the solar system, but its orbit has been modified, very likely by a gravitational influence of Jupiter. That's usually how these short period comets are formed. And this period is 6.45 years. This is a short period comet. So it will continue every 6 years. It will pass closer to the sun. It'll outgas by blowing out these plumes of vapor and shedding chunks. And eventually, like all comets, what you'll be left with is something which is like a loosely packed asteroid. It's the dust itself that's holding together only under its own gravity, because all the ice will have disappeared.
Yeah.
But that's a long process, and may take certainly millions and possibly billions of years. So it will die down eventually, but for the moment, it's very high on our list of the comets of which we are big fans.
Yes, indeed. Yeah. All right. It'd be good to see it again. It'll pass by again in the not too distant future, by the sound of it.
Yeah, there won't be anything like we saw from Rosetta, but
no.
Yes, there's certainly observations will be made.
Yeah. All right. Once again, if you want to sign up for that project, zooniverse.org is the website. This is Space Nuts with Andrew Dunkley and Fred Watson. Okay.
Right.
New right.
Right. Yeah. Just making notes about that. Our questions.
Yeah, we're doing 3 today.
That's all right.
Okay.
Okay.
All right, I'm good to go. You ready? Okay. In 3, 2, 1.
Space Nuts.
Now, if you haven't visited the Space Nuts shop lately, why not? It's on our website, spacenutspodcast.com or spacenuts.io. And for convenience sake, you click on the word shop. And that's where you'll find all sorts of collector's items. Very rare indeed, because no one's buying any. But it's got all sorts of wonderful things in it. It's got coffee cups and mugs and books. I just noticed, Fred, that Stark Craving Mad's on sale. So I don't know what that means, but anyway, it's on sale.
No, that's all right. It's probably been reminded.
Yeah, and there are polo shirts for men and women, and hoodies and hats and notepads. You name it, we've got it. It's on our shop, spacenutspodcast.com, and click on the shop link and see what there is that you'd like to get. Bubble-free stickers. Stickers are always good. And of course, as a patron, that sort of stuff, you get bonus material for sticking with us for certain periods of time. So after a few months, you'll get something. A few months later, you'll get something else. Yeah, I'm not sure I was supposed to tell you that. But anyway, now you know. Let's carry. I can't delete it. It went out live. Let's carry on, Fred. And we've got some questions. And we're going to go to the UK first because Mike saw something.
Hello, Andrew and Fred. Mike Whiting, Chroma, UK. I was looking out my window about 10 o'clock last night, laying in bed. I've got fairly bright sky around where I am, so I don't see a fantastic amount. But I was looking out towards Vega, I think. And I was looking directly at a particular star, and all of a sudden it got brighter by probably a factor of 2 over a course of about 2 seconds. Slowly faded off. Nothing. Wait, another 3 seconds. I was just wondering whether, well, I thought it could have been a number of things, but possibly supernova, which I very much don't, or possibly a reflection of a geostationary satellite. The other one was maybe a meteorite hidden straight at me through the atmosphere. So that one. Just wonder what your thoughts were.
Thank you, Mike. That's a little bit of a mystery. Could be any number of things, I suppose, Fred.
Yeah. It's very hard to, when you don't see it yourself, it's very hard to pinpoint what it is. But that's a good description from Mike. Had it been a naked eye supernova, it would have been headline news across the world because the last one of those was back in 1980.
We'll scratch that off then.
1987, I think it was, 1987A, which was in the Large Magellanic Cloud. And that was the first for nearly 400 years, so they're quite rare. And had this been, this conversation been 5 years ago or so, or maybe 4, I would have said, well, it was probably an iridium flare, because the iridium communication satellites, which were in relatively high orbits, I think they were about 600 kilometers, so they appeared to move slowly across the sky, but they had these antennas that were like large wardrobe mirrors, and if they got to be in the right angle in respect to the sun, you get this bright flash. And it looked as though it was stationary because while the satellite was moving, just the perspective made it look as though it was something brightening up often by a factor of 100 rather than a factor of 2. They were spectacular. But those Iridium satellites have now been decommissioned. Now, there probably are other things with reflective surfaces. And Mike mentioned geostationary satellites, and that's certainly a good point, because whilst geostationary satellites at 36,000 kilometers are really too faint to see with anything but a fairly big telescope, if their antennas or solar panels or whatever catch the right angle with the sun, they can come up to naked eye brightness. And in some ways, I think that might be the most likely of the explanations for what that is, because it's probably something in our local neighborhood that's reflecting sunlight. But, it's hard to know without having been there and seen it. So they're all good ideas, Mike. I think you can cross, as Andrew just did, cross off the supernova. But the others are good. And it is possible, there must be meteors that are head on.
Yes.
I've heard of people seeing them. So just a bright point of light that brightens up. Usually they're not, Mike mentioned 2 or 3 seconds. These are usually over in less than a second. And you say, what on earth was that? Yes.
Yeah. It's certainly possible, though. So if you're in the right place at the right time and the angle's perfect, it just would look like a glow and then gone, maybe.
Yeah.
All right. So we don't know, Mike.
We don't know. That's right. Could be all sorts of things.
Yeah.
But my guess, I think the most likely one is a spacecraft.
Some sort of glint.
A glint off a spacecraft, exactly.
All right. Thank you, Mike. Lovely to hear from you. Thanks for the question. Let's now head off to the United States, and it's that old terraforming Mars chestnut again.
Hey, guys. It's been a while since I've bugged you. It's me, Martin Berman Gorbine, writer extraordinaire in many genres. Was just listening to your latest episode about where you're talking about the Mars quakes, and I'm going to ask you a totally off-the-wall question about terraforming Mars. So the big problem is that it's just too darn small to hold on to an atmosphere, right? Well, suppose you could develop, put together your own miniature neutron star of degenerate matter nearby and shoot it right into the heart of Mars. Would that work to increase the mass of the planet so that it could hold on to an atmosphere? Or would you just shatter the whole planet into a bunch of pieces and end up with a late heavy bombardment of the solar system? Can't wait for the answer, because some crazy science fiction novel that I'm going to write in the future might hang on it. Love your show, guys. Keep going strong in space. Berman Gorbine out.
Thank you, Martin. I got overtaken by some degenerate matter the other day, so I know what he's talking about.
Yes,
what do you think of his theory? There's a book hanging on this, Fred. Don't forget.
I know. It's a. If you want, I like the idea of it causing a late heavy bombardment. So the late heavy bombardment is that time in about 3.8 billion years ago, when the solar system was still full of churning bits and pieces. It's where most of the craters on the moon came from, and maybe in our own era there might be a late heavy bombardment by somebody blowing up Mars. Because if you had a neutron star that was big enough to do any good, I think that's it would rip Mars to pieces and be very unstable. And you've got to figure out how you handle something like that. I don't know how you make it. I don't know how you handle it when you've made it, because everything gets spaghettified round about it. It's a little bit of a tricky one. So my view of that, I think it might be good in a comedy science fiction book. Maybe that's maybe that's where it's going, especially with the late heavy bombardment. I like that idea.
Yeah. So neutron star material, degenerate matter, not really going to do it for Mars.
Well, you'd end up with a Black Widow planet, wouldn't you?
Yes, you would. Yes, you would.
To refer
Would
back
that be
to,
too close to us? Would we not?
Yeah, we'd have problems as well. I think
Yeah.
swirling around it. The sun would lose its battle with it too. I think.
Oh,
yeah,
boy.
it's not a nice scenario, and well, you know what I think about terraforming Mars.
I do. Yeah. It sounds like it's nigh on impossible.
I think that's, I think you can forget the nigh on as well.
It's just impossible.
Yeah.
All right, Martin. I'm not sure that'll give you fuel for your book, but it's science fiction. You can do whatever you please, really. Just make it up as you go along. That's what I do.
Yeah, he does.
I do. I've been waking up at night with thoughts about a new book, and I haven't started yet, because what I want to do is I want to get parallax on audio, which I haven't done. So that might be my next project. The Hitler paradox is now available as an audio download.
Oh, good.
Yeah, which I'm pleased about. That took a long time to do, but it's taking a bit of time to get out to all outlets. But I think it's available just about everywhere now. Thank you, Martin. And finally, we go to Melbourne, Australia. This one's a good question, because I'm sure a lot of people have wondered about this.
G'day, Andrew and Fred. It's Sandy here from Melbourne again, with a follow-up question to my last one around interstellar objects. How do astronomers determine an object is from outside our solar system? My basic understanding is to do with the speed, but what threshold or other markers are used to determine an object such as a comet hasn't come from the Kuiper Belt or the Oort cloud? Thanks for answering my questions, and thanks for a great show.
Thank you, Sandy. I suppose it's like the discovery of a new world, when the early explorers were traveling and they discovered New Zealand. And I think, from what I've read, and this is pretty accurate history, when James Cook stumbled across New Zealand, he went, "Oh, look, New Zealand." I think that's how it went down. So maybe that's how we've determined where they've come from. We just looked at them and went, "Oh, look, it's an extrasolar object."
There's a bit more to it than that, but
I kind of suspected that.
You're on the right lines. The giveaway is the hyperbolic trajectory. So let's go into the mechanics of orbits. Most of the orbits of objects that we're familiar with, particularly in the solar system, are elliptical. They're, if you look at the shape that they trace out, it's an ellipse. And in fact, most of those ellipses are many of them are circular, and a circle is just a special case of an ellipse. Now, the shape of an ellipse is defined by a number called its eccentricity. And for example, for an ellipse, a bit like some of the asteroids, it might have an eccentricity of 0.5 or something like that. If the eccentricity number is between 0 and 1, then you have an elliptical orbit, something that is in a bound orbit. It will continue going around the sun or whatever object it is.
Yeah.
If you have a 0 eccentricity, that is the case of a circle. So a circular orbit has an eccentricity of 0. Now, what about an eccentricity of 1? Well, what you've got there, if you think of an ellipse, an elongated oval, and stretch it out so that one end of it goes to infinity, then it becomes a parabola. Which has an eccentricity of 1. That's a shape known as a parabola. But you can have things that have an eccentricity greater than 1. and they are called hyperbole. So an object on such a trajectory would be said to have a hyperbolic trajectory, and that is an orbit that is in no way bound to the sun, in other words, not tied to the sun. And so most Oort cloud comets will come in on a parabolic orbit. Eccentricity equals 1. You don't need to worry about all that stuff. I'm just showing off here.
I'm doing well. Yeah.
I'm going to run into trouble in a minute, I'm sure.
Even I'm impressed.
So parabolic orbit is like a very elongated ellipse, and something falling in from the Oort cloud will come in on an orbit that was either parabolic or very near parabolic. But if you've got a hyperbolic orbit, that's one that's coming in at such a high velocity that it makes this different shape. It's wider than a parabola. It's almost coming in like a V-shaped orbit as it passes by the sun, where the point of the V is its point nearest to the sun, and that's, it's the perihelion. Even though it doesn't go around another time, it just goes past once. Yeah, and that's the diagnostic for interstellar objects. If it's in a hyperbolic orbit, I think there are a few other clues that you can get from learning about.
Sandy mentioned speed. Is speed a factor?
Yeah. So the speed is a factor. In order for it to have a hyperbolic orbit, it's got to be going very fast.
Yeah.
So that's that. So I guess that's right. The two factors are the speed and the shape of the orbit.
So referring to a hyperbolic orbit, is orbit a bit of a misnomer? Is it
yes, it's not.
Or is it orbiting something?
It's not.
No.
Well, it kind of orbits the sun once.
Yeah.
So a trajectory is a better term for it, because it's not an orbit really. I loosely use the term orbit, even though it's really a trajectory.
Okay.
Thank you for that, Andrew. Good thing you're here to keep me honest.
It was a lucky guess. All right.
So is most honesty, really.
There you go, Sandy. Hopefully that has resolved your query, and thanks for sending in your question. And of course, if you would like to send questions in, you can do that via our website, spacenutspodcast.com, spacenuts.io, if you don't like to type much. And just click on the AMA tab at the top of the page. You can send text and audio questions that way, or you can send us your voice message by clicking on the Send Us Your Voice Message tab on the right-hand side of the page. It's a simple process. Don't know why we have two of them, but anyway, they work. But yes, love to receive your questions and comments anytime, and we do check them very regularly. If you don't get through, if for some reason we don't do your question, it's probably because we think it's, garbage. No, more likely we've done it before. That's the main reason people might miss out. So don't feel like you've been jilted. And if you do feel like that, it was all Fred's fault. But no, basically it's probably because we've done it before. True?
That's the usual reason, Andrew. Absolutely. Yeah.
Yeah. Okay.
And it's usually one we've done before quite recently.
Yes. No, that's true. Yes, so it's nothing personal. But, if you have a complaint, you can write to Professor Fred Watson, Astronomer at Large.
They do.
You should work in radio, Fred. You should see some of the complaints we get in radio. Oh, my goodness. Dear, oh dear. And I'm probably going to get one now. But we might wrap it up there. Fred, thank you so much. Great to talk to you again.
Always good, Andrew. And I look forward to the next time.
Indeed, which will hopefully be next week.
Maybe.
See you then. For Professor Fred Watson, Astronomer at Large, and from me, Andrew Dunkley, thanks for your company. And thanks to Hugh in the studio for pushing all the buttons and ringing all the bells and hooting all the hooters and whatever else he does. Until next time, take care, and we'll see you soon on another edition of Space Nuts. Bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.